Alright, so now we're going to move on to question number 2. On question number 2, it says, which table shows a proportional relationship? So I seen quite a few people here do one method where you count back. I didn't see very many people using the proportions in order to determine whether or not it was proportional and went through origin. And I'm going to show you the method that I've seen most people use first, and then we'll look at the proportions, which I think is probably the easier method because it's a lot faster. Now, what some people did is they said, well, let me go ahead and check the difference between this y value and this y value. And from 4 to 6, we had a change of 2. And then they went over here and said, from 1 to 2, I had a change of 1. Once they did that, they then worked backwards. And let me show you what I mean by saying that. They said, okay, well, if we're changing by 1, if I want this x value to be 0, because when x is 0, whatever y is at that point is going to be your y-intercept. And if it has any y-intercept other than 0, then it's not going to be proportional. So they said, okay, so 1 minus 1 gives me 0. And I'm going to go back 2, because right here we went up 2 units. We're going to go back 2 units. And so if I go back 2 units, that's 4 minus 2. And that's going to give me 2. So in other words, the y-intercept for this graph is 0, 2. That tells me that it is not proportional. So we can look at it and say, okay, A is not an option because it's not proportional. So we can just go ahead and mark off F and mark off H. Now that's one thing you could have done. Then if you check this one, you would have said, okay, there's a change of 1 right here and a change of 1.5 here. And if we work backwards, if I subtract 1 from 1, that gives me 0, so I went back 1. And if I go back 1.5, which is the change over here, that gets me to 0. So my y-intercept for this one is 0, 0, which means it is proportional. So we know that the answer has to be G. So the table is B, and its graph will pass through 0, 0. We've proven that. So this is one way you can do it. The other way that I was talking about when I say proportions is when we set up y over x. And that's a real quick way you can check to see whether or not it's proportional. So we look at y over x, and what we can do is we can take our y value of 4 and then put it over our 1. So watch this, I do 4 over 1, that equals 4. Then I can do my next set of points, and it's 6 over 2. So I put 6 over 2, and that gives me 3. Notice these two values are not equal to each other. So that tells me, again, that it is not proportional. Watch what happens when I check B that way. I'm going to put my y over my x. So I'm going to do 1.5 over 1, and that gives me 1.5. I can go ahead and put 3 over 2. And 3 over 2 is also equal to 1.5. And if I wanted to, I could also say, well, let's keep going and check all of them. We could have 4.5 over 3, and then we could have 6 over 4. And if this is proportional, we will get this same value repeated, which we call the constant of variation, and it'll repeat itself over and over and over again, because in a proportional graph that will occur. You'll have that constant of variation. So let's go ahead and put these two numbers in our calculator and check them real quick and just verify, although we already know it's proportional, just to go ahead and verify what's going to occur. Alright, our number we were getting was 1.5, so we're going to go ahead and put our fraction bar up. And we have 4.5 over 3. And look, it gives me 1.5. So I'm going to go ahead and try my last one. My last one was 6 over 4. So I'm going to put in my fraction bar and put a 6 over 4. I am going to put a decimal after the 4 because I want it to convert it to a decimal for me. And it's also 1.5. So that verifies that this is proportional. So now we can go ahead and say, okay, this is 1.5. This is 1.5. They are all equal, and we call that our constant of variation. And we have confirmed that G is the correct answer.